1,000 years after the Big Bang, the universe was a very different place compared to what it is today. At this point in time, the universe was still very young, and much of the matter in the universe was in the form of hot, dense plasma. The universe was still expanding rapidly, and the temperature was still very high. During this time, the first stars and galaxies were forming. As matter cooled and became more concentrated in certain areas, it began to clump together under the influence of gravity. These clumps of matter eventually grew in size and became the first galaxies. The first stars were also forming during this time, and they were much larger and hotter than the stars we observe today. As the universe continued to expand and cool, the first heavy elements, such as carbon and oxygen, began to form. These elements were formed in the cores of the first stars and were scattered throughout the universe when the stars eventually exploded as supernova. Over the next few 100 million years, the universe continued to evolve. The first galaxies grew in size and complexity, and the first planets began to form around stars. The universe was still expanding, but at a slower rate than in the early universe. As the universe continued to evolve, it entered what is known as the cosmic dark ages. During this time, there were no sources of light in the universe, and it was completely dark. However, after about 500 million years, the first sources of light began to appear. The first galaxies and stars were emitting light that began to ionize the neutral hydrogen that filled the universe. This period is known as the reionization era. By 1,000 years after the Big Bang, the universe had evolved to a point where it was unrecognizable from its early days. The first galaxies and stars had formed, and the universe was no longer a hot, dense plasma. The first heavy elements had formed, and the first planets were beginning to form around stars. However, the universe was still very young, and there was much more evolution and change to come in the billions of years that followed. During this time, the universe was still dominated by dark matter, which is a mysterious form of matter that interacts very weakly with normal matter but has a strong gravitational effect. The presence of dark matter can be inferred from its gravitational effects on galaxies and other structures in the universe, but its exact nature and properties are still not well understood. The first black holes were likely also beginning to form during this time. These are extremely dense objects that form when massive stars collapse under their own gravity. They are called black holes because their gravity is so strong that nothing, not even light, can escape from them. The cosmic microwave background radiation, which is a faint glow of radiation that pervades the entire universe, had already been emitted during the early universe, but it would take billions of years to cool down to the low temperatures at which it is observed today. The first large-scale structures in the universe, such as galaxy clusters and superclusters, were likely starting to form through the process of gravitational collapse. These structures continue to evolve and grow in size over billions of years. The universe was still expanding, but the rate of expansion was gradually slowing down due to the gravitational attraction of matter. However, it was not until much later, around 5-6 billion years after the Big Bang, that scientists discovered that the expansion of the universe was actually accelerating, likely due to the presence of dark energy, another mysterious component of the universe. The first life forms had not yet emerged in the universe, as this would require the formation of more complex chemical compounds and the right conditions for biological processes to occur. However, the seeds for life were already present in the form of the heavy elements produced by the first star. Overall, 1,000 years after the Big Bang was a time of rapid change and evolution in the universe, as the first stars and galaxies were born and the universe began to enter a new era of light and structure formation. However, there was still much to learn and discover about the universe in the billions of years that followed. In conclusion, 1,000 years after the Big Bang, the universe had already undergone significant changes compared to its early days. The first galaxies and stars had formed, and the universe was entering a new era of light and ionization. However, there was still much evolution and change to come in the billions of years that followed. The story of the universe is a long and fascinating one, and we continue to learn more about its origins and evolution through ongoing scientific research and investigation.